Hello, everybody. And as Rachel mentioned to you, I will be going a little bit more into detail into our linking procedure and creating links and some commonly encountered issues that we have when doing so. I believe I have control of the screen. So, some of the steps that need to be followed when creating a link is to, first of all, decide what needs to be linked to what. And as Rachel mentioned to you, there are several ways to create a link. And of course, it needs to be investigating on how to create it, how to have a valid link. And for example, going from a more specific to a less specific, generic class, a one-to-one relationship, etc. There are times that a lot of regulatory sources list chemicals that don't have an actual CAS number. That is, in most cases, the case for chemical groups, for example, arsenic compounds and others. And in that case, a special number has to be given to these chemical categories. Then again, specific individual substances have to be then investigated if they need to be linked to these generic links, and therefore to achieve maximum coverage of the intended regulation. Also, when new CAS numbers come into the database, they also need to be linked to several chemical group categories. Now, As it was mentioned before, the links are chosen based on their chemical relation, except in some cases where there is some exceptions. For example, there's some links that are based on relation of use or property. Let's say that a regulatory source regulates organic pesticides, and that would be a relation based on use, and it can be any type of organic pesticide, any type of substance. Or a regulatory source regulates flammable substances, for example, with that fulfill the risk phrase R10. And those can be hydrocarbons, alcohols, it doesn't matter. It just has to fulfill this type of flammable substance R10 phrase. And therefore, those are based on property. But in most cases, as said, they are on chemical relation. Now, a chemical expert has to make a decision if a link is valid or not, and there's a lot of different things that we need to base it on depending on the type of link. For example, there is oxidation numbers when it comes to metals, regulations that affect chromium-3 compounds versus chromium-6 compounds. And therefore, the oxidation state of a metal in a substance has to be investigated, or aromatic versus aliphatic hydrocarbons, ionic, covalent, organic, inorganic, and also with respect to solubility. Now, of course, we need some resources when we are doing our linking in order to follow also some rules. And these resources that help us with chemical group definitions, structures, and solubilities. For example, a UPAC Gold Book is a good source for chemical definitions. CRC Handbook and Euclid for a lot of physical property solubility data. And there's a lot of good information in the EPA Substance Registry Service, Canadian Centre for Occupational Health and Safety, the Hazardous Substances Data Bank, Chemical ID Plus for structures, etc. As was mentioned before, some of the types of links that we look for are structural isomers to its mixture of isomers, optical to a racemic mixture, individual substances to a generic chemical group, allotropes and isotopes to a parent atom, and hydrated substances to anhydrous counterparts. Of course, there's others, but just some basic ones just to keep in mind. Now, of course, there's one little thing I forgot to mention, that once we decide what type of link to create, there is a tool in LOLI desktop, and therefore we go to the link editor tool and we create the link there. So, of course, we need to maintain our link data quality. And for that matter, we have regular meetings to discuss progress and issues that arise. For example, to make decisions if there are any links that are slightly ambiguous in the regulatory source, or also to answer to link questions that come from customers or LOLI entrants. So it's kind of a dynamic procedure in terms of our discussions with customers as to what type of links we're doing and why, etc. There's also periodic checking of the links to ensure they're correct. There's sometimes chemical definitions that become obsolete. There are several cases that a link was created that is not valid. So all these we need to be checking, and we do check them periodically to make sure that they're of good quality. One thing that was for me to mention to you is, for example, in terms of sort of an executive decision would be, let's say, when it comes to soluble and insoluble compounds, there are several regulatory sources that regulate, let's say, mercury-soluble compounds and mercury-insoluble compounds. And in a lot of cases, we don't have enough data in terms of solubility to assign substance to either one of the groups. And an executive decision, for example, was to at least link them to both until we have better information. So to alert the customer that there is a possibility that a regulation is applied to that particular substance until new data comes available. So once we get this data, for example, if we find solubility data for a substance, we make sure we check it to see if we need to make any changes. I would like to go into just a couple of examples just to kind of quickly show you a little bit how our process works in terms of deciding to create a link. For example, here is the chemical group phenols that is listed in several regulatory sources, for example, in TSCA or other several EU lists. And one, when thinking of a phenol, would initially think that, okay, it's a benzene ring with a hydroxy group attached to it. But if you look at the IUPAC definition, we see that it's a more wide definition than what we were originally think. So, for example, the IUPAC definition shows that compounds having one or more hydroxy groups attached to a benzene or other arene ring can also be considered phenols. So a more inclusive definition. Now, obviously, perhaps most of the regulatory sources are actually interested in regulating only the compounds with one benzene ring and one hydroxy group. But since we're not sure, really, what its individual regulatory source regulates when it regulates phenols, then we use this more inclusive definition in that case. Another example that I will show you here is that in several cases there are ambiguities that arise due to names. And one case is the compound that you see, its structure, which you see right here on your screen. As you see in its name, this compound has chromate. And of course, if one hears chromate, immediately it kind of raises an alert that it's possibly a chromium-6 compound, and therefore it will be toxic. However, an expert looking into it will see from its structure that it's actually not a chromium-6 compound, and that the oxidation state of the chromium in this particular case is chromium-3. And the only reason for being named chromate is the fact that you have a chromium core right here and 4 oxygens around it. But that does not mean that its oxidation state is +6, and therefore it's not obviously the same toxicity that a chromium-6 compounds would have. So if you were to link it to any chromium-6 compounds, regulations that deal with chromium-6 compounds, you would be making an incorrectly regulated compound. Another quick example that I will show you is also how we choose, as I mentioned before, between regulatory or chemical. For example, there's several sources that actually list organophosphate pesticides or organophosphorus pesticides. And we have two particular numbers for it. But wouldn't these two RR links be the same? And in fact, if you look into, if you do some searching, you see that a lot of regulators and industry use many times this organophosphate and organophosphorus name as a synonym. But chemically, they're not really the same. Because you consider what organophosphate would be is basically an ester of phosphoric acid, whereas organophosphorus is actually a lot more inclusive. It can be any other type of phosphorus or organic phosphorus compounds. So therefore, you would possibly be excluding any other pesticides if they exist, and or if they will be made in the future. And therefore, in that case, you need to go by chemical relation and really separate those two, whereas perhaps the regulators actually meant the same exact thing. See, your organophosphorus pesticides is a more general link than an organophosphate pesticide. And just in closing out in my last slide, and as a prologue to what Pam Maloney and Jennifer Diley will be showing to you, I want to show you that through links, there is a complex networking that is created so that in a number of different searches, one can find some regulatory information for a particular substance, but also with the correct linking, they can find several other regulations that may have an impact on that substance. So you see, for example, in EU COP, which lists mercury organic compounds, a generic link needs to be created because there is no specific CAS number for mercury organic compounds. Once this CAS is created, individual substances that fit the bill, such as methylmercurial chloroethylmercury, need to be added, need to be linked to the mercury organic compounds. And that actually, in turn, needs to be linked to the more generic group, which is the mercury compounds. So effectively, you have from just individual substances, a larger group, and an even larger group right here, and all the different regulations that impact individual substances and also their linked generic chemical groups. And with that, I would like to pass the table to Pam Maloney, which will show you a lot of interesting examples in how links can be very useful in your searches.